Okay, we've looked at this problem once before, but it was so fun I thought we would take a look at it again. So the problem reads like this. Arrange the numbers 1 through 9 into 3 rows and 3 columns so that a 3-digit number across the middle row is twice that or double that of the top row, and the 3-digit number on the bottom row is 3 times that of the top row. And so if you saw the last video, we basically took these numbers that you're supposed to rearrange into the 3 rows, and what we did is set up variables for each digit in the row, A, B, C, for the first row, for the hundreds column, the tens columns, and the ones column. And then the same thing with the second row, we created more variables, D, E, F, and of course for the last row, G, H, I. And then we did a series of nested for loops for each one of these variables to go through the combinations for 1 through 9 for each of the positions, and then did a series of tests to see if it met the conditions up here, that we are using the 1 through 9, non-repeating, and that we have the second row is twice the first row and the third row is 3 times the top row. So I thought we might look at a little bit different solution, and what we could do is look at a row at a time. So we could have a variable called x that represents the first row, y being the second row, and of course z being the third row. So we still may have to refer to these A, B, C, D, E, F to look at individuals to make sure we don't have duplicates of the digits 1 through 9 as we rearrange these, but we're going to deal with it mostly on the row level, X, Y, and Z. So let's switch over to our code view, and we'll do the same thing. We're going to set up some for loops here, but we're going to do it at the row level. So I'm going to go ahead and put for. And then for our for loop, I'm just going to set, initialize the variable. And since we're dealing with the first or the top row, I'm going to create my variable called x, representing the number on the top row. And I'm going to initialize that to a 3-digit number. Since we're only looking at 3-digit numbers across the top, I'm going to start with 111. Remember, 0 is not included, so I don't really need to start from 0 to 99, and then we'll stop or we'll keep in the loop as long as x is less than or equal to the topmost 3-digit number would be 999. Okay, and so we'll get there by 1, so I'll do the whole x plus plus thing. And already I see we can change a few things here, because later on we're going to have to deal with duplicates. So remember, in the problem we're rearranging the numbers, so we shouldn't end up with duplicates like this. So I've already got a bad value in here, 111. So I could probably change that actually. For 111 to the first number would be 123, and then for 999 there's also a duplicate, so I'm going to change that to 987, which is the highest number without having duplicates. Okay, so I don't want 988 because the 8's are duplicated, so 987 should be the largest number where we don't duplicate, but we have the 3-digit number. Same thing for the first number. I can change that to 123 instead of 111. So that takes care of the first row loop. So we're going to go from 123 to 987. So 3-digit combinations. Now we still will have some duplicates in there that we're going to have to deal with, right? So we'll do that later. Next we'll set up the next row. So remember, the next row, the middle row, is Y. So I'll just do the same thing, int y equals, and we'll go ahead and use the same numbers here, 123 to 987. So I'll initialize that, y less than or equal to 987, and then of course y plus plus. Okay, so we're doing it a row at a time here. So still nested loops to go through every combination, but not quite as many since we're not dealing with each digit. We're going to do it in 3 for loops. So we'll go ahead and put the third row Z here, and int z 123 up to 987 z plus plus. Okay, and so the next thing we need to do is start testing our conditions to make sure we meet the conditions in the problem statement. And so the first one is our second row has to be twice that of the first row. So I'm going to just do a simple if statement here, saying if 2 times the first row, and the first row is going to be represented by x, so if 2 times x is equivalent to row 2, which is just y, then that meets one condition, right? Okay, and then we need another condition for row 3. It needs to be 3 times out of x. So instead of doing a logical and, I could do that here. I'm just going to do a nested if. So I'm going to go one more level down. If we have 3 times the third row, which is z, if that equals z, which is the third row, so 3 times the first row equals the third row, then we've met the other condition. The only other thing we have to do is make sure we don't have duplicates. Okay, and I like a solution we did in the last video. So what I need to do is actually look at each individual column and row that we looked at before, A through I, and make sure that there's no duplicates. And so let me create the variables for that now. A, B, C, D, E, F, all the way up to I. And then we need to, from each row, be able to parse out each, I almost want to say element because it almost seems like an array problem, but each column and row. So the upper left corner is A being the hundreds place of row X. So let me parse that out and say A equals, and so if I get a number like 123 for row X, to get just the hundreds place of that, I'm just going to do divided by 100. Now remember, this is C++, so this is really because X is an integer and A is an integer, this divided by 100 without the 0.0 here is going to be integer division. So that's going to chop it off. There's going to be no decimal remainder, so I'm only going to get the hundreds place for the variable A. So that'll give me the hundreds place. B is going to be the tens place for that. And so what I'm going to do is just take X, and then so essentially I want the remainder of that division, and that should give me everything left over. So I'm going to just do mod 100. Okay, and that will give me the remainder, and then I'll divide that by 10, or integer divide by 10, just to get the tens place. I don't want the ones in there, I just want the single digit that represents the tens column. Okay, so that should do that, and then all that's left is C. So for C, I want what's left over, the ones place of row X. And so I could do that by saying, well, X essentially minus A times 100. So that's the first, the hundreds place A. So I could subtract that out, and that leaves me essentially what would be B now. So I'd say minus B times 10. And that should give that to me. But this is probably more complicated than I need to do it. I could do that, or I can also just do X mod 10, and that will give me the remainder. Okay, so that should give me the ones place. So I just need to repeat this. So that gives us the first row, the hundreds, tens, and ones place for the first row. We want the same thing for Y, or the second row, but we're going to use the variables D, E, and F. So D being the hundreds place, we'll do that's the same thing. And then E, we'll do the tens place for row Y. And F being the ones place, and then we'll do the same thing for the last row Z. And now all we need to do is do our check on A through I variables to make sure there's no duplicates. And if we're looking for the numbers 1 through 9, all we're going to do is add up all the individual pieces, so A plus B plus C, all the way up through I, and see if that's equal to, and if we add up the digits 1 through 9 together, we get 45. Okay, and then I'm just going to use, I could do another if statement for this, but I'm going to do a logical AND operator. So logical AND, if A, now I want to do the combination of addition and multiplication to make sure we get the unique digits 1 through 9 and only that combination. So the way I'm going to do that is A times B times C all the way up through I. And if we multiply 1 through 9 together, we get this number here. Okay, so if we get that combination, we're fairly confident we have only the digits 1 through 9 in the variables A through I. And so that'll be our if statement. So this takes care of the rows. And so we know that the second row is double the first row. The third row is triple the first row, and now we're making sure we don't have any duplicate digits using this if statement. And so now we just need to print out our solution. So we'll do a C out, and we need to, I'll go ahead and do, since we've already broken down each column, we could print out X, Y, and Z, but instead I'm going to go ahead and print out A. And that way I can put a space in between each one. So I'm going to just do a quote, space, quote, and then we'll do the variable B and another space, and then C, and then we'll do an inline to wrap around to the next line. We're ready to print the next row. We'll do the same thing for the second row with D, E, and F. And then we'll do the same thing for the third row, G, H, I. I'll put 2 inlines there since I expect multiple solutions since we did the first problem. And just like the first problem, let's go ahead and put a solution count in here. I need another integer variable up here. We'll call it solution count or SOL count. We'll set that equal to 0 for no solutions, and then in here we'll go in and increment solution count. So if we actually get inside this if statement, we have a solution, increment the count, and then we'll add to the bottom, we need to add an output statement saying this is how many solutions we had. So there were sol count solutions, and that should give us what we want. A little bit different way. And so let's execute and run that and see how we did compared to the first time. Okay, and it comes up with 4 solutions. Looks like the same solution set we had earlier. This one looks slightly faster, 1.6. I think we had 1.7 the last time. So possibly a little bit quicker as far as the execution. But that may just be what's running on the computer at the time, right? Let me run it one more time just to see as a comparison. And pretty similar time, 1.69, almost 1.7, so pretty close to the same speed. But just a little bit different solution. You can approach it a different way. This one might be a little bit shorter code-wise because we're not dealing with quite as many nested loops that we did last time, A through I. So just a different look at the same problem to get a different solution set to demonstrate in programming that there's lots of ways to solve the same problem. So hope this was helpful, and see you next time.